Sustainable construction techniques can be termed green construction or building, since it involves the use of environmentally friendly and energy-saving process in the design. It can be defined as a construction that meets the human needs with minimum impact on the natural environment and aims to achieve energy efficiency, positive impacts on health, comfort, and improved livability for inhabitants. All of this can be achieved through the implementation of appropriate construction techniques that contribute to creating a healthy environment for the future. In order to minimize the energy demand, cost-effective, energy-efficient building need to start with architecture, design, and construction by understanding the main strategy related to use of efficient and renewable energy, water conservation and recycling, material and system reduction and selection, and finally, waste management. Sustainable construction approach usually starts from the architectural design at the preliminary sketches and understanding the main strategies. Because of simple strategies such as orientation, size of windows opening, shading, and insulation leads easily to a reduction of the net energy demand of around 30%. And at the same time, indoor comfort is improved. The passive design approach consists of different climate-responsive strategies to avoid heat transfer through the building envelope: orientation, ventilation, thermal zoning, building form and typology, building envelope design, material selection, and landscaping. The Middle East and North Africa, MENA, region is currently home to over 381 million people, and its population growth has been characterized by rapid urbanization. This means a large demand of buildings and infrastructure complicated by the challenges of conflicted induced displacement of people. Yet the MENA region is also said to be critical for the growth of green building globally over the next few years. The most important climatic aspect regarding MENA countries is that they are for the most part geographically located within the world desert belt. This means that most areas with MENA countries are characterized by a hot, semi-arid, arid or hyper-arid climate, relative humidity levels in most areas, with the exception of coastal areas, are low, and annual average solar radiation is very high. In order to design energy-efficient buildings and keep the inside of the buildings thermally pleasant in MENA countries, solar gain and heat conduction into the building should be minimized, while ventilation, evaporation, air cooling, and radiant cooling should be promoted. In the past, traditional buildings were designed and built according to passive design approach, as there was no electric equipment to control the indoor climate. Buildings in the MENA region were thus based on vernacular architecture. Therefore, there should be solution to reduce inside the building thermally comfortable while keeping the environment clean. The main techniques used in vernacular building in the MENA region are: first, compactness of building mass, where a flat roof is exposed to the sun all day long. Therefore, to reduce the roof surface, other roof forms could be considered, as they have a smaller surface exposed to sun, such as vault, dome, or pitched roof. The courtyard building offers the possibility to make use of daylight without solar heat gain. At the night, the cool night air descends into the courtyard. Sun heats up the air in the courtyard, which creates an upward draft during the day. In the late afternoon, the air raises up, supporting the natural ventilation in the building. At the night, courtyard cools down again, also using wind catcher malgoof can provide the natural ventilation in the building, especially in desert area, where openings are limited and very small. Second, the building envelope design, where building envelope should provide a sufficient daylight in the building and a minimal heat transfer through the envelope. Windows or doors can transfer heat around 5 times faster than the solid part of the envelope. This means for warm, hot climate that the size of the windows and doors has an effect on the cooling load. Accordingly, small openings help in reducing cooling load. Especially windows design is an important step in building envelope design. Daylight access reduces the need of artificial lighting. However, these openings allow solar heat gain, which can increase the cooling demand. Accordingly, the following strategies need to be considered. Positioning of windows where lighting is needed. Avoid excessive contrast and glare. Avoid direct sunlight access. Small windows in thick wall could be efficient. Third techniques is shading, where the solar heat gain creates uncomfortable high interior temperature. The most efficient way to protect a building from the solar radiation is by using different kind of shading. Use shading element or screen such as traditional mashrabiyah. Fourth technique is landscape design that can provide shade for buildings and outdoor spaces. Trees and shrubs protect buildings part from direct solar radiation. Finally, we can mention materials for a climate-responsive strategy. The properties of material are important. It can reduce the flow, storage, and release of heat in warm, hot climates. The thermal resistance, reflection, absorption, and emissivity coefficients are important factors to reduce the energy demand for cooling. Their thermal transmittance U value has a major influence on the cooling demand. It's interesting to mention vernacular architecture in Libya as an example. The Mediterranean coast and the Sahara Desert are the country's most prominent natural features. There are several mountain areas. Each region has its climate characteristics. Consequently, each region has its vernacular architecture. In coastal areas, the old city of Tripoli is compact, where the houses are surrounded by 3 neighboring houses to decrease the areas of wall exposed to heat. The streets are usually narrow, twisted, and slight curves. It includes a projection room and flying buttresses, arches, to brace and support the houses, provide more shade, and break the street length. In mountainside, we take Gharian with the troglodytes types of houses, undergrounded houses, type 1, Abu Sgifa, completely undergrounded without any elevation, type 2, Al-Fasil, partially undergrounded with some elevation, and type 3, Al-Maghara, hanging house. It's a cave-like excavation into vertical cave face. In desert side, we take Ghadames. The architecture of the old city of Ghadames is well adopted the desert life. It includes an almost unique system of covered street with the formally arranged squares to bring together the compact form and reduce exposure to the sun, and they provide complete privacy of family life and suitable conditions for social. Beside vernacular architecture, it's interesting to mention sustainable construction in contemporary MENA region. The first is Lycée Français Charles de Gaulle in Damascus, Syria. Aga Khan took an award for our architecture shortlisted project. He develops a French school campus that embodies sustainable by using the following: use of local material, natural ventilation, especially during summer, develop a usable outdoor space, shading devices about the courtyards. The second example is Masdar City in Abu Dhabi. It's one of the world's most sustainable urban communities, a low-carbon development made up of a rapidly growing clean tech cluster. It's the world's first zero-carbon, zero-waste city in the desert environs of Abu Dhabi.